I want to go through problem 241 as an example of a problem, of course, dealing with the standard normal distribution, which is a continuous probability distribution. And I'm also going to be using the table 2.10 on page 44. So for problem 41, it states the time to complete a project X is normally distributed with a population mean of 60 and a standard deviation of 40, and then it states basically how to come up with a standard score or Z values. And of course, since we're dealing with the population mean, it is simply the value for a random variable X minus the population mean divided by the standard deviation. So this is for population, known parameters of that population. And then it goes on and says, okay, but we want to know is what is the probability of coming up with our random variable X less than 62. Once again, as I said, we're going to be utilizing table 2.10. According to the formula, 62 minus 60 divided by the standard deviation of 4 will give us a plus 0.5 standard scores away. And then if we kind of go down here to 0.5, you can see 0.5 according to the table that we're using. On page 44, it states 0.6914. So yes, that would be the entire area to the left of being 0.5, positive 0.5 from the mean. So the answer is 69.15%. Now keep that in mind, just how this table is constructed. Last week I gave you dealing with another particular table for the standard normal distribution, which only isolates on half or 50%. But today, this video is looking at this problem from the perspective of 2.10, that table. So just kind of keep that in mind as you go through. I know I have another video up there that kind of explains this table to you. For B, it says, okay, what's the probability that X now is less than 66? Once again, we go through the math, and according to the math, we have a standard Z score of plus 1.5 Z's from the mean. So once again, and we kind of scroll down here and look at 1.5, you can see we're dealing with an area of 93 point, we'll say 331%, or I think our table would say 93.319. So, but they just are rounding this up. So we're saying 93.3%. That would be the entire area to the left of 66, according to the table. And once again, I just emphasize this table on page 44. Finally, C, we'll look at another perspective. Here we're saying, okay, what's the probability of coming up with a random variable X that is greater than 65? So we go through the mathematics once again, and we arrive 65 minus 60 divided by 4, we arrive at plus 0.25. Okay, now this time the part A, part B was looking at random variables being less than. This time we're looking at random variables being greater than some value, in this case 65. Scroll down here to our table, and if we go 1.225, we are looking at 89.44. Well, that's not the answer. 89.44% would be the answer if we were looking for a random variable being less than 65. We are looking for coming up with an area or the probability of X being greater than 65. So what we have to do here, we have to take the 0.8944, right? And we have to subtract that from 1, the entire area under the curve. So if we do that, 0.8944, we will come up with an area probability of approximately 10.56. So keep that in mind. This time around, random variable was greater than, so that's the reason why we had to subtract.